4.6 is transformations of exponential functions. So we did not learn exponential when we learned functions way back in chapter 1. But we are going to now do it. So our investigation is really just looking at what the parent function is. I want to know how to draw the parent function of an exponential graph. What is an exponential graph? An exponential graph is these guys. What do you notice about an exponential graph? What do you notice? They have an exponent of x, right? So the exponent is x, or a variable, right? So that's what we're looking at. If you go, wait, why is that different than what we were doing? We never had a graph where the x was in the exponent. We had x squared, right? We had x cubed, where we can do x to the power of anything, but we never had an x in the exponent. That's what makes it exponential. So that's an exponential function. Okay? When the variable is actually in the exponent. So all of these are going to have the same basic shape, just like we know what an absolute value function, a quadratic, all of that. So we're going to do a quick table of values. I'm going to show you how to do this, and then we're just going to memorize the parent function. Right? So same as what we did before, is that we do the table of values, and then you should be able to kind of memorize and calculate it in your head. So here, if I have a base of 2, so 2 to the x, the base is 2. So the base of 2. Then I'm going to do a table of values. Then I'm going to try it with a base of 3, and then we're going to try it for, and then we'll talk about what about different bases. Okay, so this is a base of 2. When I put that in, when I put negative 2 into here, what am I calculating? I'm going y equals 2 to the, and I put this in, negative 2 in, yes. Right, so that negative 2 is right here. So we're putting in this negative 2 into the exponent. Does that make sense? Right, we've never done that before. We've never had to calculate and put it in the variable into the exponent. What is that going to become? 2 to, yeah. Yeah, can we do that calculation? We're getting better at that with the negatives, right? So negative means reciprocal, and then this 2, we squared it. Okay? How about this one? This will be y equals 2 to the negative 1, right? Because that goes in here. So again, you don't have to show this. This is just your brain thinking, wait, how am I calculating that? So what would it become? 1 over 2. Okay. What is 2 to the 0? 1. Yeah, we know that one. 1. And what's y? Okay, 2 to the 1, it's just 2. We're okay for that one. And y equals 2 squared, which is 4. We okay? So again, you don't have to show this. This is just your brain thinking this. The stuff in the bubbles is always what you're thinking, and then you calculate that way. Does that make sense? Okay, can we fill in this chart, just and then we can talk about the comparison? So this would be y equals 3 to the negative 2, and then again, you don't have to show that. That's your brain thinking that. So what would I get? 1 over 9. Are you seeing a pattern? This would be 1 over 3. Anything to the 0 is 1. 3 to the 1, 3, and 3 squared, 9. So the ones that are important to me is, look, this will always be anything to the exponent 0 will be 1. So all of my exponential functions will have that. Then, depending on what my base is, this one here will tell me my base. Right? Because right here, can you see the base is 3? And you can see the base. When it has an exponent of 1, you'll see the base. So when I graph these two, I don't need you memorizing a bunch of functions, a bunch of points. I want you to calculate it in your head. So 2 to the x. When I graph that, right away you know 2 to the 0 is 1. So plot that point. That'll be, oops, sorry. So we know it'll be for sure 2 to the 0. Oh, we don't know. Down here, I'll move up here. Okay? Anything to the 0 will be 1 for both graphs. Does that make sense? Anything to the 0 will be 1. We know that about exponents. Then if I have a base of 2, I know that at 1, it'll be at 2. At 2, it'll be at, square it, 4. Does that make sense? And I've got 3 lovely points there. I don't need any more. So at 0, 2 to the 0 is 1. 2 to the 1 is 1. 2 squared is 4. Gorgeous? And so what this is going to look like, now what happens over here though? What happens here on this side? See how it goes 1/2, 1/4. It's going to get small. It's going to get so small. It's going to get closer and closer and closer, closer. Never touches. What's that called again? Asymptote. There we go. We get another asymptote. So we learned in chapter 1 the reciprocal one, right, with the asymptote. We have another one. Where's my asymptote? At, what's the equation of that line? Y equals 0. Are we going to number it or label it? Yes, we are. Always label that guy. Draw it, label it. I do that with my grade 12s. Draw it, label it, draw it, label it. Draw dotted lines and label it. And we're going to do this beautiful thing here. And it grows. So to the power of 3, it'll go pretty high. So I'm just going to do... So just make sure it goes high. Don't make it look wide. It's supposed to go high. Right? So it goes higher, not wider. So when you say something grows exponentially, you mean fast. Okay? So if I say, wow, that was an exponential growth in your grades, you're like, whoa, fast. So fast. So don't make it look wide. So just shoot it up high. It should go to 8. So I think it goes to 8 and then 16, etc. Okay? So don't try to widen it. It's not like that. Okay? So that's this one. I'll label that one. So this one here is y equals 2 to the x, right? I'm going to do in blue, okay, the blue, I'm going to go same thing. So can I graph 3 to the x? Okay, so we know it goes through there, for sure, right? That's for sure it goes through there. At 1, it'll be at, if the base is 3, 3 to the 1 is 3. What's 3 squared? 9. 9. Done. I don't need any of these fraction points. Just show me that it approaches an asymptote. Don't plot those. I don't want 1/9 and 1/81 and 1. So just show me these nice points. That's beautiful. And then make it go whoosh. Whoops, sorry. I missed my dot a little. And this is y equals 3 to the x. Faster. So it just keeps going faster and faster, right? That, sorry, my graph's off. I'm going to try to fix that a little. There we go. A little bit better. Now it feels wobbly here. Okay, a little bit better. There you go. But that's my graph. So exponential has always got a horizontal asymptote on one side, and it floats up there. What happens if it's a fraction? It's exactly flipped. And look at this little exactly. So it's going to be exactly the opposite, but facing the other way. Let's look at your values. So when I put in... Look, when I put in the values, so let's look at our table of values. You never have to do the table of values again, okay, until we do transformations. And when we do the transformations, I'll show you. So we're going to do transformations tomorrow or the next lesson with the left, right, up, down, horizontal, right, all that stretching and stuff. So we'll do the table of values then. For graphing the parent function, you don't have to show me the table of values. We're doing the transformations. We'll talk about that later and how many points we want to do. I don't really like the fractional points because then they're not really useful. So I usually do my nice solid points. So for a 1/2, is it still going to be 0? Is it going to give me 1? Yes. What about 1/3? All to the 0? It'll still be 1. So these guys will still be the same. Is that okay? So these guys, no matter what, I'll go through there. But when I go to the power of 1, 1/2 to the power of 1 is 1/2. Ugh, right? I have fractions. 1/2 to the power of 2 is 1/4. But what happens if I went to the negative 1? What's 1/2 to the negative 1? Yeah.
It goes 2.
2.
It goes 2,
Yes.
and then it's squared.
It's the opposite of this one, right? So then what happens is that when you graph this guy, so let's graph this one over here, it's still going to be 1, and here it'll be fractions on this side, but look, when you go negative 1, it'll go 2, negative 2, it'll go 4, negative 3, it'll go 8, like it'll go up this way. So it's exactly, I'll do this in red, same as this red one here, but flipped. Right, so it's the exact same function except the opposite way. That should make sense because, I'll let you copy that. Okay, I'll let you copy that for a second, and then I want to talk about it, about why that makes sense. Okay, so try 3. 1/3 without doing the table of values, just to get the idea, and we'll do table of values after. So 1/3 would still be 0, okay? At 1 it'd be 1/3, at 2 it'd be 1/9, really small. So we know over here at negative 1, what would it be? What's 1/3 to the negative 1? 3. What's 1/3 to the negative 2? It goes backwards, 9. And why is that? It's because, let me show you. So this is y equals 1/3 to the x, and this is y equals 1/2 to the x. Okay, move this down. The reason why they're exact opposites is because this is actually, when you think of this, this is the same thing as 2 to the negative x. Does that make sense? Is this not the same thing? The negative makes this 1 over, and it's to the x. That negative actually makes it a horizontal reflection. So anything with the x makes it a horizontal reflection. Anything in front of it will be a vertical reflection. So is this horizontally reflected? Look at the red. It's horizontally reflected back and forth. These are horizontal. This is this, which is a horizontal reflection of y equals 2 to the x. So this 1/2 is actually a negative in the exponent, which makes it a horizontal reflection. Does that make sense? So that's why they'll always be mirrors of each other, horizontal reflections. We're going to do more of the reflection stuff the next lesson. Okay, but that gets you the idea of the parent function. So we've got the parent function now, we're good. So depending on the base, we can draw the parent function. And then we'll do the transformations after. Okay, that's it. Any other questions with that?